Our task this week is to construct a test plan. And part of constructing the test plan is making some tough choices about what should be done and what shouldn't be done. Not every project can be fit into the same test plan. There's no template, much less any framework test plan that can be used everywhere. Every company you work at will have their own test plan. Sometimes inside the company, there'll be different ways of formatting the test plan. Some companies will have Word documents. Some companies will have Excel spreadsheets, or whatever the equivalents there are, of documents or spreadsheets or whatever out there. Some companies do it all electronically inside of some tool system and use their bug management to track what's going on with tests. There's so many different ways of organizing it at the high and low level details. In my estimation, you need some document, though, to give the high-level plan. You need some place for somebody to start and say, hey, this is what we're trying to do. This is what our goals are. This is our requirements, if you will, of testing and the reason we've made choices there. So as you do your plan must be specific. You must consider your application. Are you selling pizza on a website? Well, then security of credit cards is important, but I don't, performance, it's like, we're not going to have a million users buying our pizza. We can't bake that much pizza. So maybe we'll have 100 people a day. That's less of a concern. Again, that's an example of being very custom and specific within there. If you're saying, oh, mine is Department of Defense and I'm building a system to manage drone traffic, well, the integrity of that has to be massive high. The performance has to be, very well checked out. The security has to be very well checked out. All that sort of stuff would require very formalized testing. Your testing should be up to the needs of quality, but not anymore. The easy answer is to do everything or do very little. But the correct answer is somewhere in between based off of the circumstances of your project. So we want you to talk about what features are you being developed, what's the nature of the system, but also who's involved. Who are the teams doing this testing? Maybe you're making them up as you go. They don't have to be real people. And then what's the impact of failures? If something does not get tested, it goes out there, what's the cost? I mean, honestly, there's some stuff that goes out with bugs in it. Video games all the time go out with bugs in it. They just kind of hope that people won't get to them before they can get the patch out there, particularly computer-based, PC games. Level 19 has a bug, but it's going to be at least a day before we get that out there. So that's going to be for the super users. So if we get it out next week, it'll be okay. So you have to understand what's the criticality of your application. In some applications, the code just has to work all the time. It's not a video game. People's lives are on the line. I've worked in several different types of things. Department of Defense applications. I worked on airplane project. I worked on a large payment system for the government. EFTPS, it's called, the Electronic Federal Tax Payment System. It's a long time ago before they rearranged it, but it was still two pieces. I worked on that. And it's really important that the federal government gets its money because it can be very expensive to go and get the money if you do it wrong. And if you're collecting money, you want to do it as cheaply as you can. So sometimes it has to work really, really well. And there's so many different permutations. You want to validate every single line of code and every single option of those lines of code. Again, not every application is like that. It's not to say that every application is not important. Just the probability of something going wrong at the micro level is low. And if the worst case scenario is hit refresh, start over again, and don't hit that same combination, well, that's acceptable. I mean, I can't restart an application on an airplane, hopefully in time before we hit the ground. That's not a good thing. But I can get away with that if it's a video game or something like that. Hey, just if you keep jumping on this one rock and the game crashes, stop jumping on that rock. So sometimes a project really is just kind of a quick sweep. I've just made a few changes to the project. You might have an application like that. Like, hey, I am doing a video game, and I know that jumping on that rock is not part of the important flow, but we fixed that in version 3. And so everything else is the same. All we did was fix jumping on the rock. So let me test jumping on the rock and then walk through the level, make sure everything else is good, then we release it. Again, I don't have to test everything. It's what regression test is all about. That's where you plan in your regression testing using existing tests to say, yeah, this is what I do. I go and make sure I can log in and make my payment, and I'm good to go. That's the core part of it, even though I might have changed something else. So This type of testing is there to minimize the disruption to your whole project, to your whole plan, and particularly minimize the effort and the cost of doing that testing. So another thing to consider in your project is, do you have the need for integrity of entirely total independence? Do you need to have verification and validation? That's what V&V stands for. Activities completely done by somebody who didn't even talk to the developers. I once worked for a guy. I mean, these developers, they sat around the corner from us. I mean, the testers, they sat around the corner from us. We knew who they were. But he insisted that the testers not share their test cases with us before we finished writing the code, because they might influence the way we write the code, and we would code to the test cases and then pass them, but there'd still be other problems out there. And it's I guess the logic is, if I study to the test, I don't have a conceptual understanding of everything else, except for in software. Why would I be testing things that aren't out there? I mean, yes, I could maybe answer your multiple choice question, but not answer the essay question. But software doesn't have an essay question. It only does the discrete things you ask it to do. So sometimes independence is a little bit silly, but often it is really important. Because, for instance, if you worked in the casino industry, those slot machines have not only independent testers, but independent people who look over the code. I don't want you sneaking in a little code combination that automatically makes you a winner every time, as the developer, or you give to somebody else to make them a winner. So that requires absolute independence. Once you finish the code, it gets shipped over to somebody else who inspects that code. If they find something wrong, well, you're in big, big trouble, probably at least with the law. One other aspect you have to consider in your project is cost. The easy answer, as I said, is do a lot. But if the budget's tight and you still need quality, what's the minimum you can do and still have a strong level of quality, but not break the budget, break the bank, be able to still get something good done, but not have to spend all year doing it. And testing time is money. You're already going to spend money doing multiple test cycles. What's ways I can maybe cut that down or simplify that and test the most important things, or maybe phase the testing out and still get my delivery done, or something along those lines. So your key is to customize the code you're going to be doing, the test plan you're going to be doing. You need to make choices on each one of the test phases whether or not you're going to include that test phase. So let's walk through some of the discussion of the value and ways you can maybe simplify a phase if you so chose. So unit testing, it's done as part of development anyway. You're going to be doing it. You can't release code without having done some level of testing. And so really the difference is adding some formality to it. Just writing down what you plan on doing for the testing and allowing you to repeat that, because you're going to repeat that testing if you find a bug, if you make a change at some point. Now, the reality of it is expensive to do it. It's not necessarily twice the amount of time, but it's certainly 25 to 50% more time than it would be to just build the code on its own. So doing it all formally does have more money spent and a longer schedule. You have to choose the areas perhaps that are most important to automate tests. You don't have to test everything, just pick the most important stuff. Or have other people write the testing in parallel, or come back and do that after I release the code if schedule's more important than budget. You will be testing pieces of this even if you don't do any formal unit testing. You're going to test everything at some point. I once worked on a project, a very important project. We did 0 unit testing. We just wrote the code, thought it was good enough, and sent it over. Because we were doing so much functional testing, it would have been redundant effort. Even if we said it was fine, they're going to retest it anyway. They tested every line of code. So there's no need for us to do it as developers. So the integration phase, again, is something that's already done as part of development. I have to know my system works together. And having that step out there makes the plan more realistic, the whole project plan. It tells everybody, when is it time to install in this new integrated environment? What is the people who needs to be online? So are the network people there? Are the security people there? Are the database people there? Having everybody online at that time is helpful for minimizing tracking people down. Realistically, if you don't have time for it, you don't have budget for it, you can do it with some other part of the testing effort. I mean, fundamentally, it's generally one time only. Once I, put the furniture into my house and set it down, I don't come back every day to make sure it's still there. I mean, the first time through, I'm like, hey, do I like it there? Yeah, that's pretty good. If I'm not changing anything, it's good. I don't have to double check it all the time. So once things are integrated, they're integrated. Now, functional testing, you got to do. There's really no way around it. You can't not do functional testing. It's what checks the requirements out. It's the core of testings. You can speed it up in interesting ways. You can do it in phased approaches. You can release part of the functionality, release other stuff later on. You can focus on the mission critical features and maybe come back to some of the nice to have. So, hey, as I said, as long as I can buy stuff from the website, I'm not totally worried if the member, profile manager's up to speed yet, that you can customize the colors and font up there. We'll either turn that on later on, or just if it's broken, it's broken. So long as I can buy stuff, that's all I care about. That's really the strategies around functional testing. You can't get out of it. You can't get out of not doing it. It's what testing is. Now, the one phase that people normally don't bother to include in their plan is performance testing. The reality is even if your functionality is perfect, if I can't get more than 3 people on the site at a time to use it, it's useless. Think of the first rollout of healthcare.gov. Their functionality was tested. It worked really, really well. The issue was the 3 million people who went out the first day and tried to use their site, mostly out of curiosity. I mean, I will admit, I work in the industry. I work in healthcare, health insurance, I should say. I was curious. I went out there. I tried to see what their site looked like because it was we were one of the insurers out there, but I was curious, what were the prices looking like? What is the experience looking like? I wasn't planning on buying anything, so I wasn't too upset when it told me it couldn't handle me, but I'm sure if somebody really wanted that health insurance, they would have been, because it's great functionality, and some people were able to buy health insurance, but many, many, many more were not because the performance testing had not happened yet. And so this not only gives us assurance that it'll work the first day, it gives us some insights to when it will break if I do the full version of this. So by doing it, I can know, hey, I can handle 1,000 users day one. If we only have 500 to get started, that's fine. But once I get around 800, I better add more servers or rewrite some code or get a faster processor or add some more memory or whatever I need to do. So one of the things you can do to get around this is not do it, though some projects do, is focus more on just making sure you're meeting the need. Can I handle 500 users? Then trying to stress the system and see, well, can I handle 1,000 users, 10,000 users, 100,000 users? How many users does it take to break my system? Just get a core feature that is, what is the requirement? What do we need to get done? Figure out, hey, if I have 2 weeks to do performance testing, what can I get done in 2 weeks? If my project's running late, maybe I start performance testing even still just to get a baseline. Where are we at, even if things are still not totally done? Possibly I can do it after I release, just to keep up with this and get a feel for it. Remember, this is kind of like baselining your health statistics. You want to know, what is my blood pressure? What is my weight? What is my cholesterol numbers? Because that way next year I know, did they go up or down? So sometimes I want to do performance testing, not so much before I release, but just to get the numbers to know what's happening. And then regression testing we talked about. It's an inexpensive, easy little spot check you might do at different times in your project. So I know I'm going to have a release, and then I'm going to make some more changes. Maybe I'm going to do a quick spot check of, did I break anything that was already out there and working? It gives us that extra assurance. I can work around this often by just bringing in some experts and saying, hey, do I need to test this if I'm changing that? So, okay, if you change the tires on your car, no, there's no way it can influence the programming of the radio. So you're going to keep your radio stations on side of there. I don't need to test that again. Yeah, that sounds fair. Okay, we don't need to test that. We don't need to run that test. So that sort of analysis can sometimes get you around the need for regression testing. But regression testing can also be as simple as just to have a user sit down and make sure everything works. It doesn't even necessarily need to be formal. Just make sure all your happy paths are still working. This post-release cycle then is a nice set of tests that basically assures that once it's out in the wild, on the user's new desktop, up on the website the first time, that everything still works. You don't have to do it, but then all of a sudden you find out errors when users start calling in saying, hey, I can't get stuff done, or your traffic goes down to nothing, or you see reviews of your website saying, yeah, it's a terrible site, it's unusable. And so it's a little bit of prevention. The big thing about this, you don't need to create new tests for this. You can use things from your regression test plan or your other tests just to execute them. Create some fake users, some trusted users, have them walk through this. Be creative on that. And it's really just something you can do in a couple hours the day of a release.